Welcome to the second lesson on organic chemistry reactions. Today we're going to do the Northwest September 2025. Now let's get to it without the waste of time. The flow diagram below shows how a chloroalkane can be used to prepare other organic compounds. Now the other organic compounds here, as you can see in the diagram below, which means that other organic compounds come from the chloroalkane through some certain reactions. Alright, now let's get to it without the waste of time. Consider reaction 1. We are considering reaction 1. Write down the type of reaction that is represented by reaction 1. That is only for 1 mark. Guys, I've written some important information up here. Look at the important information here. This is the summary here that we have on top here, and then this is some of the information. The triple S SU USA, as you can remember from the previous lesson, the triple S SU USA. From saturated to saturated, it gives a substitution, and then from saturated to unsaturated, that's elimination. From unsaturated to saturated, we know is addition. And then there is a summary. We are going to use the summary on top to answer the questions. Now let's use the summary to answer the question. We are going to use the triple S SU USA to answer the first question. Question 4.1.1. The type of reaction that is represented by reaction 1, because they said we must consider reaction 1, right? What is the type of reaction that is happening? We know a chloroalkane, guys, is a haloalkane. So what we are having here is a haloalkane, which is a chloroalkane, and then this arrow is going to an alcohol, which means we are moving from a chloroalkane, which is a haloalkane, to an alcohol. The haloalkane is saturated, right? What about the alcohol? The alcohol is also saturated. We know from saturated to saturated, it is substitution, right? Remember, from saturated to saturated gives us substitution. Okay, from saturated to saturated, that is substitution. That's what we are having there. Now that was the first question there. So therefore the type of reaction is substitution. That's what we are having there, and then you've got yourself 1 mark there. Now let's go to question 4.1.2. 4.1.2 it says write down the IUPAC name of the chloroalkane. Look at what you're given in the table, guys. Look at what you're given in the table. Look at the reaction 4, from an alcohol, which is alcohol A, to propyl methanoate. Look at that. We know that this is an ester here, and we know that to combine an ester, you must combine an alcohol together with a carboxylic acid. The name ester is propyl methanoate. That is an ester, right? But look at the first part, which is the propyl. The propyl represents the alcohol. Look at this propyl here. I'm going to indicate it in blue. Propyl represents the alcohol. So it means that the alcohol is the 3 carbons, and we know that the alcohol in the formation of an ester, it must end with the YL. Okay, it must end with the YL. So the methanoate will represent the carboxylic acid, but the propyl, the first part, represents the alcohol. So which means the alcohol has 3 carbons. All right, that's what we're going to have. So this alcohol here, I'm going to represent it here. Alright, it has 3 carbons, so I'm going to say 1, 2, 3. So let's add the OH in the first carbon. So this is the OH. Okay, now it becomes that alcohol. So that alcohol is in the carbon number 1. That OH is in the carbon number 1. So now we have got that alcohol, which is the propanol or prop-1-ol. We already can see that alcohol A has to be the propanol. It has 3 carbon atoms. So it means also here the chloroalkane will also have the 3 carbon atoms. Alright, so that chloroalkane will have 3 carbon atoms also. So let me draw the structure of that chloroalkane in question 4.1.2. It has 3 carbon atoms, and we know that since the OH is in the first carbon, so it means that that chlorine atom is also going to be in the first carbon. That's what it means. The chlorine atom is going to be in the first carbon, because we know that what happened here is substitution. The chlorine atom in the chloroalkane was substituted with OH to get the alcohol. That's what happened there, right? Hence it's called substitution. If the OH group is in the first carbon, so it means the chlorine atom must also be in the first carbon. So first to first, right? So the IUPAC name here, guys, is going to be 1-chloropropane. That is 1-chloropropane. That is the IUPAC name, the 1-chloropropane. Now let's go to question 4.2. Is alcohol A primary, a secondary, or tertiary? Guys, take a look at your alcohol there. Alcohol A. We can see that alcohol A is propanol or propan-1-ol. Right, now take a look at carbon number 1, the one that is carrying the OH. What is it bonded to? It's bonded to one other carbon atom. Look at that. I'm going to show it in pink. Right, this carbon atom that is carrying the OH, is bonded to one other carbon atom. Then it means that it's the primary alcohol. But But what about the secondary alcohol? The secondary alcohol, the carbon that is carrying the OH. So let me give you an example here. For the secondary alcohol, this carbon here that is carrying the OH group, the hydroxyl group, is bonded to 1 and 2. So it's bonded to 2 other carbon atoms. That's why we are saying it's going to be a secondary alcohol. But what about the tertiary alcohol now? Let me give an example of a tertiary alcohol. For the tertiary alcohol, guys, this is an example of a tertiary alcohol. Alright, so what is going to happen here, the carbon that is carrying the OH will be bonded to 3 other carbon atoms. And remember this, I'm showing this in pink. Alright, so it means it's bonded to 1, 2, and 3. So that's a tertiary alcohol. The carbon that is carrying the OH, it's bonded to 3 other carbon atoms, 1, 2, 3. So those are the examples of primary, secondary, and tertiary. So what is our answer there? It is a primary alcohol. So that's how you'd answer that question. First mark, primary alcohol, and then the 2 marks will be for the explanation. So that is the explanation there, the one that I've pasted now, right? That is for 3 marks. Right now, question 4.3, guys. We are told that reaction 2 is elimination reaction. And so in the first question there, question 4.3.1, what is the type of elimination reaction in reaction 2? Let's go to reaction 2. Guys, you can see here, we are moving from an alcohol to compound B. Alright, from an alcohol to compound B. What type of elimination reaction is that? Guys, to answer this question, we are going to use our summary. I'm going to refer you to the summary because it's very important. The summary is very important to use, alright? Look at the summary. From an alcohol, we must perform elimination reaction. So look at this. From an alcohol, which arrow has the elimination? Which arrow has the elimination reaction? We can see it's the arrow that is going to an alkene. Can you see that, guys? So your summary will always help you. Otherwise, you'll find these questions very difficult for you, alright? So we're moving from an alcohol to an alkene. That is elimination. And what type of elimination reaction is that? We know it's going to be the dehydration. So the question says what type of elimination that? We are going to say is dehydration. So the answer there is dehydration. Let's note it down that compound B is an alkene. Let's write it down there. It's going to help us. Alright, the type of elimination reaction, let's write the answer there. It is dehydration. Right, now let's move on to another question. The balanced equation using the condensed structural formula for the reaction. That is reaction 2, right? We know that for reaction 2, we are moving from an alcohol to forming an alkene. Now they want a condensed structural formulae, alright, for the reaction. Now guys, to write the condensed structural formulae, we are going to start with the structural formulae. We are going to start with structural formulae first, and then we are going to condense it. Now let's do that down here. We know that we are moving from an alcohol. An alcohol is the propanol. So this is my alcohol here, which is the propanol, and we want to react it so that we form an alkene. Look at your summary, guys. From an alcohol, what are we reacting with here to form an alkene? We know that we must put the sulfuric acid. The concentrated sulfuric acid is going to be our reaction condition here to form an alkene. Now let's do that. So this is an alcohol under the reaction concentrated sulfuric acid. Now the concentrated sulfuric acid is going to act as the dehydrating agent. Remember, the concentrated sulfuric acid has 2 functions. It is to remove the water, which acts as a dehydrating agent, and the second function is it acts as a catalyst, which means it speeds up the rate of the chemical reaction. Now here in this case, it acts as a dehydrating agent, which means it's going to remove the water molecule. In order to remove the water molecule, which means we are actually removing the OH together with the hydrogen on the other carbon, the carbon next to it. So on the first carbon, we're going to remove the OH, and then on the second carbon, we're going to remove the hydrogen atom. Now that is going to form water in blue, alright? So let's form the water there, the water molecule. Now we are going to form water, and we are going to form an alkene, alright? After dehydrating or removing the water, we know that carbon number 1 and 2 are going to be left unstable, which means they won't have a maximum of 4 bonds around the carbons. We won't be having the maximum of 4 bonds around the carbon number 1 and carbon number 2. And in order to balance that, to have a maximum of 4 bonds, we need to put the double bond, alright? Plus, so our double bond of the alkene, guys, is going to be in the first carbon. And the trick is here, because the OH group is in the first carbon, so it means also the double bond is in the first carbon. And also look at this, guys, your haloalkane, the chlorine atom is in the first carbon. So that's why we're saying the alkene here, the double bond of the alkene must be also in the first carbon. That is the other trick that I can give you, alright? Now let's put the hydrogen atoms here. Now this, guys, is the balanced structural formula of that reaction there, which is reaction 2. That is the balanced structural. We need to convert it to the condensed structural formula. We need the condensed structural formula, not the structural formula. So we're going to convert this to the condensed structural formula. Now to write this condensed structural formula, I'm going to start from carbon number 3. All right, now carbon number 3, I'm now going to say it's carbon number 1. So carbon number 3, I'm now going to say it's carbon number 1. So this is carbon number 1, carbon number 2, carbon number 3. The main reason is that I want to end with the OH. That is the main reason. Okay, you can start counting from the left hand side going to the right hand side, or you can start counting from the right hand side going to the left hand side. That doesn't matter. Here's the first carbon, and then how many hydrogens? 3 hydrogens, right? So it's 3 hydrogens here. The second carbon, I'm looking at the pink numbers, right? The first carbon is that one, second carbon 2. Now the third carbon has 2 hydrogens, right? 2 hydrogens excluding the OH, all right? 2 hydrogens excluding the OH. Now the OH here, we're going to write it separate like this, OH. Don't combine these hydrogen atoms here. This hydrogen atom here, the CH2 here, doesn't combine with the H of the OH. All right, this is NP. We can make a lot of mistakes here. This is NP. We are going to move now to the product. All right, let's move to the product. We are going to write H2O here. Going to say plus the first carbon here. The first carbon, how many hydrogens are we having? 2 hydrogen atoms. All right, 2 hydrogen atom. And then in the second carbon, there's only 1 hydrogen atom. How about third carbon? 3 hydrogen atoms. This is your condensed structural formula. We have got our 3 marks there. That's what we are having. Now let's go to question 4.4. Write down the IUPAC name of the compound C formed in reaction 3. Now let's consider the reaction 3 there. This is our reaction 3 here. Now reaction 3, we are moving from compound B, which is an alkene, and then we are adding the diatomic molecule of hydrogen to form compound C. Guys, your summary is going to help you. We know that this is going to be the addition reaction because it's hydration. Okay, it's hydrogenation. This is hydrogenation. From an alkene, adding the diatomic molecule of a hydrogen, that is hydrogenation to form compound C. Look at your summary here. From an alkene to an alkane. All right, we are going upwards. Look at the arrow that is going upwards. The arrow on the left hand side, we are moving from an alkene to an alkane. What are we adding there? We have added the diatomic molecule of hydrogen, so it means it's hydrogenation, and that is addition reaction because we are actually moving from the unsaturated to saturated. And according to the triple S USA here, from unsaturated to saturated, we know it's addition. But what type of addition reaction is that? It is hydrogenation. That's what we're having there. What do they want? They want the IUPAC name of the alkane that is formed, which is the compound C that is formed here. All right, from compound B, which is an alkane, adding the diatomic molecule of hydrogen to form compound C. Compound C, let's write it here, right? Let's write it just there. This is our compound C that we're going to form here. It has also 3 carbon atoms. Remember, the alkene had a double bond. The alkene had a double bond there. But because we're adding the 2 hydrogen atoms here, the double bond is going to be broken. So it means we are no longer going to have a double bond. We are just going to put the hydrogen atoms there. Let me show the 2 hydrogen atoms that we've added in pink. These are the 2 hydrogen atoms that we've added. The other one is going to come in carbon number 1, and the other one is going to come to carbon number 2. That is the alkane that we formed. So this is an alkane here. That is your alkane that we formed. It is the propane. So what is the IUPAC name of that? It is propane. That is propane there. All right, so I've made a reaction here for you to understand. This is question 4.4 for you to understand the product that we're forming here. This hydrogen atom here will go and bond in the first carbon. This other hydrogen atom will go to the second carbon there. So we're going to have here, and remember this reaction is under the reaction condition platinum, palladium, or the nickel. All right, so I've shown the reaction there. All right, just for in case if someone doesn't understand what happened there. All right, so that is question 4.4. Our product is propane. That's why we said here in question 4.4, that's why we said it's propane. Now let's go to question 4.5, right? 4.5. Now question 4.5.1. Name the formula of the catalyst used. That is reaction 4. Now they are saying consider reaction 4. Now reaction 4 here, guys, is from an alcohol and forming an ester. We know that from an alcohol forming an ester, from the previous lesson we have said this is esterification. And what is the reaction condition? The reaction condition is the concentrated sulfuric acid. But if you don't remember that, here is the summary. From an alcohol here going to an ester, we know that we are going to add the carboxylic acid. The alcohol is going to be added with the carboxylic acid or reacted with the carboxylic acid to form an ester under the reaction condition, concentrated sulfuric acid and some heat, of course. Now, name or the formula of the catalyst used. We know that the catalyst that is used here, it is the concentrated sulfuric acid. So that is the concentrated sulfuric acid there, and then you'll get your 1 mark. Now let's go to question 4.5.2. They want a balanced equation using the structural formula of this reaction here. Remember, we are looking at the reaction 4. A reaction 4 which is from an alcohol to an ester. Now this alcohol, we have that alcohol, it is propanol. Propanol is going to react with the ethanoic acid. This alcohol is going to react with the ethanoic acid. But do we know the ethanoic acid? Yes, we know the ethanoic acid, because remember the methanoate part, this part methanoate represents the what? Carboxylic acid. It represents the carboxylic acid. And in this case here, we know that carboxylic acid is the methanoic acid. So it's the carboxylic acid here. This part represents the carboxylic acid. So that carboxylic acid is the methanoic acid. So we are reacting the propanol with the methanoic acid to form an ester. Let us show that reaction. This is what is going to happen. The propanol. From the previous lessons, I said you must write it in this manner. The alcohol, you must write it in this manner. That OH, you must start with the hydrogen atom followed by the oxygen atom. To make the reaction easier, that you must have something called CHO. This is going to be called CHO. We're making the reaction easier. Now, let's put the hydrogen atom. So this is my alcohol, propanol, alright? Now that propanol, we know that we are going to react it with the methanoic acid. Remember the methanoic acid, me means 1. I'm talking about myself, right? So it will mean 1 carbon. It means 1 carbon. So this is my methanoic acid, 1, 2, 3. Make sure it has 4 bonds around it. But remember, when you put the OH, you must start with the hydrogen followed by the oxygen. This is what is going to happen, guys. This is my methanoic acid. This OH here is going to steal the hydrogen from the methanoic acid, and we're going to form water. So after the hydrogen is stolen there, we understand and know that this oxygen atom on the methanoic acid, this oxygen that is here, will be left overhanging. So if it is overhanging, we understand that it will decide to bond with the carbon of the alcohol, and then it will also decide to bond with the carbon of the ethanoic acid. Therefore now we're going to form an ester. Look at your ester now. So that is the structural formula of the ester that we have formed. If you want to name this, they only want the structure, guys. It's not necessary for you to name. Don't name this. They want the structural formula. So if you want to name, we're going to start with the alcohol. The first part will be the alcohol, and we know that the alcohol will be propyl. Remember that your alcohol must end with the YL, so the YL is important. But how are we going to name the last part? Now the last part, guys, we know that it is going to form an 8. Just circle the oxygen atoms. Can you see it's forming an 8? After forming an 8, you ask yourself, how many carbon atoms are we having here? Only 1. 1 means meth, so it's methanoate. Now it's forming an 8. The noate sounds like an 8, so it sounds like an 8, so it's going to be the methanoate. So that is your IUPAC name there, but they only wanted the structural formula, and it must be balanced. Balanced meaning that the number of carbons on the left hand side must be equal to the number of carbons on the right hand side, and also the number of hydrogens on the left hand side must be equal to the number of hydrogens on the right hand side. That's what it means, balanced. All right, now we can see that here it's balanced. Now thank you for watching, guys. God bless.